So here's the third in a series of 9 videos to help you with the number patterns questions. And this time we've got a pattern that doesn't go up by a fixed amount every time, because it goes up by 7, then up by 14, then up by 28. Perhaps you can see that what's happening every time is you're doubling the terms, times 2, times 2, times 2. So for our patterns in words, we could write each term is double the previous one. What could we write next? All of the terms are even except for the first one. All terms are even except the first. That could be something we could write as an observation in words, except the first. Terrible handwriting there. Okay, so let's have a look at how we're going to generate an algebraic rule for this pattern. Just get rid of that lot there. So the first term is 7, and because we're doubling every time, the second term is 7 times 2, and then the third term is just the previous one multiplied by another 2, so it's 7 times 2 squared. 7 times 4, 28. And then the next one after that you're multiplying by another 2, so the next one is 7 times 2 cubed, and it's always 7 times 2 to the something, and that something is always 1 less than the position you are in the sequence. So we would expect, for example, term number 100 to be 7 times 2 to the power of 99. And generally speaking, we would expect the nth term to be 7 times 2 to the power of n minus 1. So for our algebraic rule, we want to write r equals 7 times 2 to the power of n minus 1. And in fact, a geometric sequence is always the first term multiplied by the common ratio, 2 in this case, to the power of n minus 1. Okay, so now with the, well, let's first of all just complete the table. So if we're doubling every time, we're expecting this to go 112, 224, 448, 896. And we're going to test and verify the rule. So when n equals 3, my rule says that r should be 7 times 2 to the power of n minus 1. So r equals 7 times 2 to the power of 3 minus 1. R equals 7 times 2 squared. R equals 28, which indeed it does, 28 there. So we make the observation, this matches the value in the table, and that should get us the mark for testing. And then verifying is almost exactly the same thing. It's just we're doing it for something higher up in the table, for example 7, where we had to fill in the prediction. So when n equals 7, my rule says r equals 7 times 2 to the power of n minus 1. So that's 7 times 2 to the power of 7 minus 1. So that's 7 times 2 to the power of 6, which is 7 times 2, 4, 8, 16, 32, 64. And 7 times 64 is 448. And lo and behold, this matches the value in the table. So I can just sort of, copy paste that comment. This matches the value in the, copy, paste, and use it again. This matches the value in the table, copy, paste, get rid of that, whatever it is. And job done for that question.